All right, so we're going to work number 1 together first. It says in triangle ABC, A is 12 and B is 5. So you can really label those on your triangle. This side is 12, this side is 5. It says what are the trig, the 3 trig values, functions. Gosh, I can't say that right today. What are the values of the 3 trig functions of the angle B? You guys, when it tells you what angle to look at, that's the angle you have to look at and then label your triangle from that. So from angle B, this side over here would be my opposite side. Do you remember doing the labeling of the triangles? This side right here would be my hypotenuse. And then this side is the, yeah, it's the adjacent side. So really what I can do now is find my sine, cosine, and tangent functions if I have the hypotenuse of my triangle. Do anybody remember how to find the hypotenuse?
A squared plus B squared.
That's exactly right. A squared plus B squared equals C squared. That's the Pythagorean theorem. Our C value is always going to be the hypotenuse. So we're going to substitute those numbers in. I'm going to go 5 squared plus 12 squared equals C squared. And I'm just going to finish solving that. 5 squared is 25. 12 squared is 144. I add those together, I get 169. And then I would square root that. So my C value is going to be 13. Now that didn't actually solve anything that they asked me to solve for yet, right? That just gave me the side of my triangle. So now that I have the side of my triangle, I can find my values. So my sine of angle B is the opposite over the hypotenuse. That's the rule. So the opposite would be 5. The hypotenuse is 13, so 5 over 13. The cosine rule says it's adjacent over hypotenuse. So the adjacent is, yeah, 12 and over 13 again. Nice. The tangent rule says opposite over adjacent. So the opposite is, oh wait, opposite over, yeah, there we go. There we go. 5 over 12 is right. Okay. So number 2 and number 3 on this worksheet work exactly like that. So let's jump over and look at maybe number 4. Okay. Number 4 says if angle A equals 35 degrees, so I like to just label my triangle as I go, and side C is 22, what is the length of side A? So I'm actually looking for this side over here. So I like to go and label my triangle from the angle that they gave me. So from this acute angle that they gave me, this side over here is going to be the opposite side. And what's the other side that they gave me? Yeah, it's the hypotenuse because it's opposite the right angle. Now what I'm going to do is find which one of those 3 trig functions actually uses the opposite and the hypotenuse. So which trig function uses opposite and yeah, it's the sine. And I like to just write down the rule. The rule says the sine of the angle equals the opposite over the hypotenuse. And I'm just going to substitute my information into that formula. So what's the angle?
35.
Yeah, so the sine of 35 equals the opposite, which I don't know. I'm going to call it the letter A because that's what it is here, over the hypotenuse, which is 22. Now, if you remember when I taught you how to do this, I asked you to just put a 1 underneath that and cross multiply. So on your calculator, you can do the sine of 35 and then times that value by 22. The other direction, you get 1 times A, so you just get A.
So
12.61?
12.62.
12.62 for our answer for the side of A. Does that make sense how I use those trig functions again to solve for that? Okay. So number 5 is going to work exactly the same way, but in order for you to do this, you're going to have to draw your own triangle to help. Okay. All right, let's flip over and let's look at angle measures on the next side. Let's look at number 6. Then we'll do number 6 and number 7 together. So we're going from radian measure to degree measure, or from degree measure to radian measure. And if you look right up here, it tells you exactly what to do. To convert from radians to degrees, multiply the angle by 180 over pi. And then to convert from degrees to radians, multiply the angle by pi over 180. So we just got to look at which direction we're going and use the right formula. So I'm already in degrees, and I'm going to radians. So what am I going to multiply the 225 by? Yep, and then I really can just let my calculator do the work. I can use the pi key on my calculator and punch it in and just let the calculator reduce that fraction for me. 5 pi over 4. Thank you. Questions on how I did that? I like these problems. They're just like plug it in the formula kind of thing, right? All right, the other one goes the opposite direction. So this time I'm going to take that 5 pi over 2 and I'm going to times it by 180 over pi. Because I'm going from radians to degrees, I need those pi's to cancel out, which is why it needs to be on the bottom here. The pi's cancel, and if you punch that in your calculator, it will do that for you. Just let me know what you get. I think it's 450. Yeah. So 450 degrees. All right, the next two problems work that exact same way. You just have to figure out which formula to use. Let's skip over to number 10 and look at it. So number 10 says find one angle with positive measure and one angle with negative measure that's coterminal with the angle in 265 degrees. So coterminal really means add or subtract rotations, right? Do you remember how much a full rotation is in degrees? Yeah, a full rotation is 360 degrees. So if I want to add a full rotation to this, I'm going to add 360 degrees. And then when I want to subtract a full rotation off of that, I'm going to subtract the 360 degrees. So 265 degrees plus 360 degrees is how much? 625. 625.
And then negative 95.
And then negative 95. Okay, the same thing happens like on number 11 but on number 11 it's in radians. So what do you add and subtract on radians?
Pi.
Yeah, at 2 pi. So you're going to add 2 pi and you're going to subtract 2 pi. I'm not going to do that for you, but just remember a full rotation is 360 degrees or 2 pi. Okay. All right, next kind of problem over on the other side. Now these ones were before we started working with the unit circle, so we're not on the unit circle with these. It would be nice if we were on the unit circle, but this is just an angle in standard position. So we need to kind of graph it, and I'll show you how we did it, and then I'll remind you how I showed you could do it without actually graphing it. But we're over -5, and we're down 12. Are you right if I just kind of call this down 12 right here? Because actually I'm not down 12. I'm up 12. I almost did that one backwards. So I'm over 5 and I'm up 12. We're just going to call that 12 up there, okay? My angle comes through the origin, just like that. And I'm going to do a right triangle to the closest x-axis. So I'm going to come down right here and draw my right triangle. So I know this length right here is 5, and I know that length right there is 12. I'm going to throw my negative sign on that because I like to keep the signs on it. So I'm -5, +12. And in order to find the radius of this circle that would go through here, I'm going to do the Pythagorean theorem. So I'm going to go -5 squared plus 12 squared equals r squared. And I'm going to solve. You could totally do c squared if you wanted to. It's the same formula. That's why my r kind of looks like a c, because I started writing c and then I changed it to r. But a -5 times a -5 is a +25. 12 squared is 144. And this is really similar to a problem we already did just a second ago, right? This adds up to 169. Then we square root and we get r equals 13. So then when we did our sine values, our sine was y over r, our cosine was x over r, and our tangent was y over x. And we just had to use those values that we had. So y over r, my y value is my up and down, so it's 12, but you can also look up here at your ordered pair. So 12 over 13 for my sine value. My cosine value would be my x over r, so my negative 5 over 13. And then lastly, my tangent value is y over x. Y is 12, x is negative 5. So you can put that negative up on the top. We don't ever change it from an improper fraction. We're always going to leave it that way. So then, you guys, just a reminder that you can totally draw your triangle that way and see it visually. But if you wanted to, you could just call this x, call this y, and start solving with x squared plus y squared equals r squared, and go from there and go straight to your formulas. So that's how that number 15 is going to work, the same way that number 14 did. Okay. These next ones ask you to graph them, or to sketch the graph of the angle. So 285 degrees, if you remember, the initial side of our angle always starts on the positive x-axis, and then we go counterclockwise. So from here to here is 90, this is 180, here comes to 270, and then I just have to go 15 more degrees after 270 to get to 280 degrees. So that angle would be 280 degrees. Does that make sense how we did that? Now it actually says find the reference angle. Now if you remember what the reference angle was, the reference angle is the angle to the closest x-axis. So I'm really just asking you how many degrees is it from where I drew my angle to the closest x-axis. Well, I was 285 all the way from here to here. I actually know that that was 15 degrees past 270. So I really can figure out how far I am from my angle to the x-axis. How many degrees away am I? $75 degrees, right? Because there's, out of the full rotation, there's 360 degrees left. So I'm going to go 360 minus 285, and that's going to get me that reference angle. You do the same thing when you're in radian form. So if you remember, like on this one, 7 pi 8, this is not more than 1 pi, because 7 is less than 8. So I really only have to worry about the top, which is a full pi, and I'm going to break it into 8 different pieces. So 1, 2, 3, 4, 5,